Hello again, everybody. It's lovely to remotely meet you again. So as I was just very nicely introduced there, I am Ezzie Pearson. I am a space journalist, which basically I always say that means it's my job to be enthusiastic about space, which is a nice job to have. But that I've been doing that for about 10 years now. But that journey actually started because of, in part, what I'm going to talk about tonight, the Chelyabinsk Meteor. So how did that start? What is the Chelyabinsk Meteor? Well, I'd like to take you back in time, if I may, back in time 10 years ago to the morning of the 15th of February 2013. It was about 9 a.m. local time in that region, which is about 3 in the morning UTC, in a region called the Chelyabinsk Oblast of Russia, which you can see, hopefully here, highlighted in red, down at the bottom. And it was the morning of the 15th of February. Everybody in the region of Chelyabinsk in the town of Chelyabinsk was heading off towards work when they saw something rather unusual in the night sky. And there's a slight hint of what this might be because, of the name of the talk. But as everybody's going into work, they suddenly saw this bright light coming across the sky. And it was very, very bright. As you can see, it was actually, when it reaches its brightest, it was many, many times brighter than the sun was. So it was a very short but incredibly bright flash of light. Some people saw it moving across the sky from a distance, slowly moving and then brightening up suddenly. And here are some more still images that people managed to capture of this thing as it was coming across the night sky, the day sky even. And this happened at about 9:20 a.m. local time. And as you would expect, there's something strange happening in the sky. There's a bright light coming across. So everybody went to the window to have a look. People were looking out of their cars. People went outside, started chatting about what was that bright thing that we'd seen in the sky, which was a bit of a problem when 2 to 3 minutes later, this happened. I don't know if you can hear the audio on this, but there's people saying things like, was that Sputnik? Is one of the things that was being said. And then suddenly there was this loud bang that was very, very loud, fills the air. And a shock wave that was enough to blow out all of the windows. In this case, it's setting off the car alarm as well. And this was a warehouse in the region, and it was so powerful, the shockwave, that actually took the roof down. And that's the one I always like to leave the video running to. It was so powerful, it pushed that man through a wall. So it was this absolutely huge shockwave that just resonated across the whole region. And that was a bit of a problem because, as I said, people had been interested to see what this thing was. So they'd all gone up to the windows, and then the windows got blown up, the walls came down. Fortunately, nobody was very badly hurt by this, but there was an estimated about 1,500 people had suffered minor injuries. Most of these were actually sunburn. It was so bright, even though it was for a short time, it burnt people's skin and caused quite a lot of retina damage as well to people's eyes. The next biggest sort of culprit was glass. So glass coming out of these windows, it hit people in the face. And again, thankfully, most people, it was just minor cuts and abrasions. So there wasn't any serious problems that was caused by this. But it did cause about 1 billion rubles worth of damage, which is a couple of million. It was enough to be a significant amount of money that needed to get paid out to refurbish the area. And people also reported there being a smell of sulfur or burning ashes in the air. So it was quite an experience for these people who were there at the time. And another thing that people noticed was they heard something just after that initial explosion. They heard something falling down and rattling across the roofs of like rain, they said. And what that actually was meteorites falling out of the sky. Because whilst some people did think that, yes, maybe this was something sinister, such as a missile attack, quite a few people did realize what it actually was. This was a meteor, albeit a very, very big one. So just before we go any further, a little bit of nomenclature for you. What is a meteor? Well, a meteoroid is a space rock that's out in space. Sometimes call them asteroids as well, space rocks, that sort of thing. If it's in space, that's what it is. As soon as it hits Earth's atmosphere, that's when it becomes a meteor and it's shooting through the sky. Ones that are particularly bright are sometimes referred to as fireballs or bolides. Generally, if it's brighter than the planet Venus, then that's when it's referred to as a fireball. They're the sorts of ones where if you see one in the night sky, it will draw your attention. So they're very, very bright. Bolides are ones that then explode with a bright amount of light. Anything that reaches the ground from that, however, is what we call a meteorite. So in space, meteoroid, in the atmosphere, meteor, on the ground, meteorite. I do try and keep them straight. I do sometimes say the wrong one, so apologies if I do that. But back to 2013, a lot of people had actually been looking up at the night sky, expecting to see asteroids because a very big one had been passing. It was called DA14 2012. But this one, so people weren't entirely sure whether this meteor was related to that or whether it was something completely different. So that was one of the big questions. And it very quickly became apparent that the one that had been seen in Chelyabinsk was just coming in completely the wrong direction. So it can't have been related to that one. It was, in fact, it had come out of the direction of the sun, and that's why people hadn't been able to see it. It's a strategy that fighter pilots used to use during the World War, which is if you fly in towards the enemy from the direction of the sun, they're dazzled, they can't see you. And that's exactly what happened with this asteroid, this meteor. That's why we never saw it. But the meteorite fell in this region of Chelyabinsk in Russia. And it actually turns out that Russia has quite a long history of meteorites and meteorite discovery, or just strange space phenomena exploding above Russia generally, which is what happened in 1908 with what's called the Tunguska event. And this was basically in 1908, people in the surrounding area of Russia, around this region called Tunguska, they felt and heard that same shockwave for miles and miles around. But the actual explosion happened over a very remote area of forest. And when people went out to that remote area of forest, they realized that all of the trees had been blown down. There was been some kind of big airburst had happened and just flattened the entire area. And even at that time, they thought, oh, this must have been a meteor or possibly even a comet hitting Earth's atmosphere and exploding above this region. Thankfully, it happened in a very unpopulated area, which is why nobody was hurt. There were apparently some deer that were found that did not have a good time from this massive explosion, but as far as we know, no people were hurt in this. This time, in 2013, so a century later, the explosion happened over a much more populated area. And whilst that meant that more people were affected, there were more injuries. It also meant that there were lots of witnesses. Particularly, there were lots of people who caught it on camera. And part of that is just, there's more cameras around these days. But also, if you've ever been driving in Russia, there is a reason why everybody has dash cams on their car. There's quite a lot of road accidents that happen. We, in fact, got into one whilst I was out there visiting, but I'll get onto that later. So there's lots of cameras and there's lots of footage. So that meant that they could begin to immediately start to analyze what happened during this event. So this is the general region around where the asteroid, the meteor, was seen. And one of the first things you can do when this happened, is people started posting about it on their social media, Twitter, Facebook, and things like that. So it very quickly became apparent where this thing had been seen. It had been seen in the town of Chelyabinsk, into the region south of it. People had seen it coming from the direction over to the east, moving towards the west, was the direction that it had been moving. So people were able to very quickly ascertain what direction it had been coming. And that was how they managed to establish that this wasn't related to that other asteroid that people had been paying attention to, and they knew it was about. This was something completely unseen that nobody had witnessed before. And as it became more apparent that an event had happened, something exciting had happened, people started going out and looking in the surrounding region, because this meteor, it had come over Chelyabinsk, it'd been heading towards the west. So could they find where it had finally come down? And in the end, they think they did, in the region of Lake Chelyabinsk. So this was a big frozen over lake that they found. They went out to this lake and they found a big hole in the middle of the lake. Now, there was no way to guarantee that this was caused by the meteor, but generally speaking, if you've got a frozen over lake one day, then a big space rock comes from space and a big hole in your lake the next day, it's probably a safe bet to say the two might be related. So there was an 8-meter wide hole that they found in this frozen lake. Unfortunately, it was February in Russia. Nobody was going to go down there and actually check to see if there had been anything that had fallen, not for another couple of months, because that would be foolish. So, but they still reckon that they could say with pretty good confidence that this was the point where the meteor had ended up. That was the end point of where it had come. Now, by this point, it was beginning to become the day for the rest of the world, or, the Western world. The UK was beginning to wake up, reading all of these things on social media, seeing news outlets picking up on this event that had happened over in Russia. And they were checking their own instruments to see if there was any sign of what had happened. This is a reading taken from one of the CTBTO listening stations, which is the Comprehensive Nuclear Test Ban Treaty Organization. And they have 45 stations all around the world. They listen in infrasound. So infrasound is, if ultrasound is high frequencies, infrasound is very, very low frequencies. And these travel right the way through Earth. They travel enormous distances, and they are created by big explosions. The sound stations are actually listening out for the distinctive sounds of people testing nuclear weapons, but they also detect things like earthquakes, and in this case, huge meteors exploding. And from people who are experts in this, it was very obvious that this wasn't a nuclear test. I believe I have here. So the top two are what it looks like if you see a nuclear test, and the bottom is an earthquake. And if you compare the nuclear tests, which have that sort of very sharp beginning at the beginning and then tail off, here you can see there's a bit more of a sort of ring up and ring down on those patterns here. So they did look very different to the people who can read these in a bit more detail. So people knew very much straight away this wasn't a man-made phenomenon. This was something natural had happened. And it very much looked like a meteor had exploded, which was good because that's what everybody thought had happened. But they'd also managed to work out how much energy got put into the atmosphere by this from these measurements. It turned out that there had been 15 kilotons of energy had got from this detonation, which is about 30 times the bomb that was dropped on Hiroshima. So it might not have been a bomb, but it was as big as one. Fortunately, it appears to have happened quite high up in the atmosphere rather than right down on the ground. And another thing that was very useful was because lots of people had seen it, lots of people had caught it on camera. What's the first thing you do if you capture something like this? You load it up onto the internet. And that meant people could start doing things like this. So someone had taken this footage from a CCTV camera in the square in Chelyabinsk Square. And by measuring the height of the lampposts, how far they were apart, taking how far they were apart from Google Maps, by the way, and then measuring the rate at which the shadows move, depending on whether it's the sun creating them or the meteor as it goes past. People began to work out the path that this meteor had taken through the sky above Chelyabinsk. And by doing that from a couple of different videos, various people around the world were beginning to build a picture of more detail of exactly where this meteor had come from, what it was. And it appears to have been that there was an airburst about 30 kilometers above the landscape. So the airburst was when it broke apart and scattered all of those meteorites down onto the ground. And it happened when it was going at about 19 kilometers per second. This asteroid was traveling at about 19 kilometers per second when it hit the atmosphere, and it was coming in at an angle of about 18 degrees. And what happened when it had that airburst at 30 kilometers was and it was the thing that created this explosion. The asteroid, when it's coming in from space, it hits the atmosphere and it's going so fast that the air around it superheats. And this, as the air superheats around it, and that's actually when you see the glow of a meteor or a shooting star, you're not seeing the rock itself ablate, what that's called, the fancy word for burning up. What you're actually seeing is the air around it getting super, super hot and glowing bright white. And in this case, what that did is it made that chunk of asteroid, that meteor, got so hot that it just broke apart. All of the sort of natural fissures in the rock broke apart. And when that happened, they flew apart at such great speed. This rock was going at 19 kilometers per second. So even just a small deflection in the which direction it's going going hugely faster than the speed of sound. And that's what happened basically. The rock split apart, started flying in slightly different directions. That's what created the shock wave. That's what created the Big Bang. And in fact, it actually broke apart several times. There were several different explosions that were seen. I believe there were 7 in total, 7 different explosions as it slowly broke apart. And as it broke apart, it also crumbled. And that, as it crumbled, it scattered its rocks all across the landscape beneath it. And that's what people heard falling from the sky like rain, was these meteorites falling from the sky and scattering down as this rock just crumbled and fell apart under these huge strains of coming through the atmosphere at incredible speeds. And by looking at all the videos, they'd managed to put together the path that this meteor had taken through the sky and managed to work out where it had come from. But why is that important? Why do you need to know what direction this meteor came from? What can you actually learn from it? Well, if you know where it came from through our atmosphere, you can backtrack that and work out where it came from in the solar system. You can begin to work out its orbit. And that means they did just that. And they found that this meteor had been, meteoroid, this asteroid, had been going around the sun, crossing Earth's orbits for potentially millions of years, going just sort of within Earth's orbit and then coming out beyond the orbit of Mars out towards the asteroid belt and then looping back around. And it probably done this thousands, millions of times without ever hitting Earth. But this time it happened to be that Earth was in the way. So here again, we see a video which is just showing in a bit more detail exactly where the Chelyabinsk meteoroid was in relation to Earth. And this was its position 4 years before the time of impact. And in a minute, it will get started. And so here, it had been going across. And so 2 years before, it had quite happily crossed Earth's orbit, but Earth hadn't been there, so nothing had happened. And it just so happened that this time, Earth and the meteoroid crossed paths at the same time, and that's why the impact happened. This helps people to work out where the asteroid might have come from initially, because as I said, that orbit went from about the orbit of Earth, but right the way out to the asteroid belt. So people were pretty sure that this asteroid had initially, in the dim and distant past, come from the asteroid belt. But something had happened that had knocked it inwards. So what is the asteroid belt? The asteroid belt is a region of lots and lots of space rocks that are between about 1 and 2 times the Earth-Sun distance away. And that's where most of the asteroids that we know about within our solar system live. Sometimes there are some that are scattered inwards in towards the inner solar system, and some which hang out in other sort of gravitationally stable orbits near Jupiter, called the Trojans and the Greeks. But most of them are in that asteroid belt. Even so, there's only about 4% of the mass of the moon worth of mass in terms of space rock in that asteroid belt. So it's not actually that hugely busy going on. In fact, if you were standing on most of the asteroids in the belt, you would need a pair of binoculars to see your neighbor. They're quite far apart. It's not like in the movies. But it's still close enough that when you're talking about the timescales of the solar system over billions of years, they will occasionally hit into each other and knock each other about in where they are. And that's how we get the inner ones in the inner solar system, the Earth-crossing asteroids, they're called. Those happen because something in the asteroid belt, there's a collision, and it tends to might chip off one from a larger asteroid, or just change the orbit of a smaller one and send it off towards the inner solar system. And occasionally those space rocks do collide with our planet, as happened on that day. But where do all of these rocks come from? Why are there so much rock flying around in the inner solar system? Well, that is a big question, and one that was answered with the help of this. Excuse me. No, that's not what I'm going. So this was actually a different meteorite. This was the Chakotay alien meteor. This was the first meteorite that was ever the first meteorite that was ever made the connection between asteroids and meteorites. It was discovered in the 12th of February, 1947, near Eastern Russia, in Eastern Russia, near the Sea of Japan. So again, another Russian meteorite. There's lots of meteorites found in Russia, and some of them are very significant, including this one. And this was discovered in 1947. And similar to the Chelyabinsk Meteor, people had seen it coming in. It hadn't been recorded on cameras because they just weren't around back in those days. But people had seen it coming in. People got dispatched to go and try and find to see if there was any meteorites. And people found them, found this meteorite, picked it up and realized, yes, meteorites come from shooting stars. They come from asteroids. By backtracking them, they managed to track it all the way back to that asteroid belt and find it. And so that was how they made that first connection. It's the first ever direct evidence. But back in 2013, this meteorite had exploded in the air, as I said, and it had scattered all of these rocks all over the surrounding landscape. And in fact, this inspired a great rush to go and find those meteorites. Just as they had done it back in 1947, they knew that there would be meteorites scattered across the landscape. And so a lot of people wanted to go and find them. This was a map that was created by the Ural University, who were a nearby university with a meteorite department, who sent out researchers to go and find as many of these space rocks as they could. Each of the red dots is an individual rock that they found. The size of the dot is how big it was. That red kind of ellipse at the beginning, that was under the main airburst that happened, that first airburst that happened. And that was just, they found so many in that region that it's just a big red blur. So lots and lots of meteorites were found in that area. But it wasn't just researchers from the local university that got dispatched. There were hundreds of people that went out to try and find these meteorites. There was a bit of a great big meteorite hunt going on. A lot of those were local people who were trying to find some that they could sell, but there's also people coming from further abroad, international investigators, people trying to sell them, and members of the media, such as myself. This is where I come in on the story. So I was still doing my PhD at the time. I was just beginning to get into space journalism. And I got a phone call on that morning saying, hey, would you like to come on BBC News and talk about this explosion that had happened? And I said, yes. Somebody saw me on that and said, hey, do you want to go to Russia to shoot a documentary about this explosion that's happened, about these meteorites and how people have found them? Which I immediately said yes, because that sounded like an amazing adventure. And so I got dispatched out to the region of Chelyabinsk in the middle of February to try and report on this discovery that was going on. And there was lots of people out here hunting for meteorites. And it turns out that actually Russia, in the middle of winter in a very rural area, is one of the perfect places to try and find meteorites, because there's pristine white snow everywhere. People don't go walking through it, all of this, just huge fields covered in this white snow. And that means if you've got this pristine snowfield and you see a hole in the snow, that it's not, it might be a mouse or something, but it's not like the rock on the bottom has jumped up through the snow. Chances are it's something has come from the sky and dropped down through it. And these rocks are very, very hot when they hit the ground. So it melts the snow as it goes. And that means you can search the snow looking for these holes and try, and that's how you end up actually finding meteorites. And so if you ever do find yourself in a snowfield trying to find meteorites, the way that you do it is you look for one of these holes, hope it isn't a mouse, and then you dig around that hole, trying to clear away the snow away until you've got sort of like a big column of snow. and then dig from the bottom and try and lift it up. And hopefully you should find there's this sort of column of snow and ice with a rock frozen to the top of it. That column's caused because, as I said, the rock's very hot. It melts the snow as it falls. It refreezes to form this big column. So you should be quite clear whether or not you found one of these things. And fortunately, there was lots of people who went out to go and find these. The Russian government was a little bit possessive. They didn't like people taking huge amounts of them away, but they did realize that people were coming into this country to try and do it. Thankfully, though, there was a lot of people who went out to try and gather this because, as well as being something that people like to sell, it's a hugely important scientific resource. And there was lots of people from the Herefordshire University, including Viktor Groskovsky. You can see his hands there on the right. That is a kilogram rock, which was the biggest single piece that they found from the fall, from lying on the ground. It was absolutely huge, and it felt so incredibly heavy. But they found lots and lots of pieces of rock from the research institute, and they took it away where they could research it properly. However, the biggest payday that they got actually didn't come for several more months until October, on the 16th of October, 2013, when they raised this rock from the bottom of the lake so that the hole in Lake Chelyabinsk that they had found, they had to wait for the lake to thaw, for it to get slightly warmer. So they wanted the summer for the water to warm up. And then at the end of the summer, in the autumn, they went and fished the rock out of the lake. They spent a lot of time trying to bring it up in one piece. They pumped mud away. They spent months wrapping it up carefully taking it up, using metal sheets to try and slide it out, and eventually got this rock out of the lake entirely in one piece. They put it on the scales, broke the scales, eventually found out that it was about 540 kilograms each-ish. So this absolutely huge space rock, and they got it all out in one piece, and then they unwrapped it, and it immediately broke into 3 pieces. So it wasn't the best day, but they did manage to get this massive rock out of the lake. There was initially some debate about whether or not this was actually part of the meteor or whether it was just a random rock from the bottom of the lake. But I think now the wisdom is that actually this was the last bit of the meteorite that had survived its way to Earth. And as you can see, this rock is probably a meter and a half wide. The initial space rock, they think, was probably more like 15, 20 meters across. So it was quite a big one when it came in, and a lot of it got burnt away or crumbled away and formed meteorites, and this one space rock that got left behind. But one of the things that's really interesting is that they could then begin to start to analyze the rocks, such as getting it underneath an electron microscope, such as this. And this was some of the first measurements that they did. In that colorful picture, each of those, that's the same section of rock, but in different wavelengths, and you can begin to see different minerals and different things that it's made up of, and beginning to analyze what this rock is. But why do they actually care what kind of rock it was? Well, they care because asteroids are the leftovers from the beginnings of the solar system. So when the planets formed, there was a lot of debris flying around. We think there was actually probably quite a few more planets in the beginning than actually finally made it to be planets, but they collided and got destroyed. And that's what the asteroid belt is. It's made up of the material that didn't quite make it to be planets. And different types of asteroids tell us different things about the formation of the planets. So what kind of meteorite was the Chelyabinsk one? What could it tell us about those early formations? Well, it turns out that it was what's known as a chondrite. So these are stony meteorites. They're called non-metallic. They do actually generally have a much higher metal content than Earth rocks, but compared to most space rocks, they're very poor in metals. It was around 4.5 billion years old because chondrites are the earliest kinds of meteorites that there are. They are created by, they were created, this was the primordial material which the planets got built out of. So chondrite asteroids formed, and then they slowly built up to form the planets. But not all of them ever got to be a planet. So this was the bit that never even made it anywhere near being a planet. It just sort of got left out. About 85% of meteors of asteroids in space are thought to be chondrites. And they are the leftovers from initial star formation. But what was really unique about this particular one is it had a lot of what are called shock veins. So, in fact, I can have my rock. This was one that we found out. Well, I say we found. A person on the side of the street, one of the locals found it, and then we bought it off him, so that he could buy an iPod, I believe was what he was trying to do. And I don't know whether I can get that in the camera, but you can hopefully see that there's this black crust all over it. That black crust is what's called a fusion crust. The fusion crust is created by that superheating. It melts the outer layer of the rock and forms that black crust when it starts to cool. But these black veins that are running through it, those were created long, long ago. So at some point in this rock's past, it has smashed into something else. There's been a huge event that sends shockwaves through the rock. That's caused certain parts of it to melt and then reform, creating those veins. And that are very, very weak points within the rock. And in fact, that's probably why the Chelyabinsk meteorite crumbled so much, why it broke apart several times, why it scattered so many small rocks all over the place. It was just a sort of loosely held together pile of rubble, and these shock veins going through it just caused it to fall apart. However, in 2022, so 2 years ago, a researcher called Craig Walton was able to use these shock veins to trace the past collision history of the asteroid that eventually became the Chelyabinsk meteor. Because if you can measure the age at which all of these different shocks were created, you can begin to tell at what points in this rock's past did it hit against something else? When did it have that big collision? And he did this by measuring various minerals within the rock. He did something called isotope measurements, so certain radioactive decays over time. I believe it was uranium to lead. So uranium decays into lead. When something gets heated up, the uranium gets stuck. It remains stuck in the rock, but the lead can escape. So you can tell by the ratio of those two to each other how long it's been since that vein got made. And what Craig found was that there appears to have been two major impacts in that space rock's life. There was one about 1 million years ago, which was probably the event that chipped it off and sent it into the inner solar system. But there was also another big impact about 4.5 billion years ago. So very early on in this space rock's life. And that's very interesting because a lot of other meteorites also show signs that around about that time, there was lots of impacts happening. Lots of meteorites show an impact about 4.5 billion years ago. It's also about the same time as our moon formed. And our moon formed by a planetoid about the size of Mars hitting the early Earth, and the stream of debris coalesced to form the moon. So it certainly seems like 4.5 billion years ago in our solar system's history, something was happening. There was a lot of explosion, lot of impacts going on. And these impacts are really important in informing our understanding of how the solar system formed and what went on. There's lots of different theories about what could have caused those different impacts, because this was quite a while after the solar system formed. So the solar system formed about 5 billion years ago, things quieted down. And then when it was about 500 million years old, suddenly there was all of these impacts again. So something had caused that. And some people think it was the gas giants and so on moving through different orbits. It's a theory called migration, that planets Jupiter and Saturn used to be at different orbits and then
I've lost you there, Ezzy.
hear me?
Yeah, it might be just me, or I just
I don't know, can everybody else hear me?
No, it was definitely off.
We lost you, but you're back now.
Okay,
Okay.
You're
right,
back
that's
now.
good. Thank you, everybody. If we can all remute. Carry on.
Hopefully that's okay. So yes, it tells us about the history of the solar system. And asteroids are also very important because they can tell us about the history of planet formation as well. Because whilst chondrites never made it to be planets, a lot of asteroids were in planets that then got destroyed. And what that means is by one of these huge impacts into each other. And what happens when a planet gets big enough is it starts to do something called differentiate. So you get all of this planetary material, all of these space rocks coming together and forming this big ball. They eventually have enough mass that they form a sphere. And eventually it gets hot enough in the core that they start melting in the core. And that's when differentiation happens. So all of the metals and the heavy stuff sinks to the bottom and you form that big metal core. Then further around it, you get the mantle and then the crust on the top, just as you find in our own planet. But if that planet is destroyed when it's very young, then all of those different layers also get thrown out. So the core, which is usually like locked away very deep inside of a planet, we can, by looking at a meteorite that was once part of the core of a planet, we can begin to understand what it was formed. Let me say that again. So these planets get destroyed and all of the different layers of the planet become different types of meteorites, different types of asteroids. And so by looking at those asteroids, we can begin to understand different layers of the planet that we normally wouldn't be able to reach and to access. So for instance, in the core, that's where we find iron. They form iron meteorites. These were the cores of those planetesimals. They are very, very solid. They only form about 5% of meteorites, but they make up 90% of the mass of meteorites that we found. They are incredibly heavy. They are just solid lumps of metal. They were also some of the earliest sources of iron that was ever found by early civilizations. I always think that's a fancy trope of people saying, I forged this blade out of star metal. No, that was a thing that actually happened. People found meteorites and made them into early weapons and so on. They are some of the ones that sort of make it to Earth in the best shape because they don't break up, because they're not covered in shock fractures. They're not likely to break up under the stresses of going through the atmosphere. They are also quite pretty. They are, because of the way that they cool in space, it's a much slower process of cooling iron than you would have on Earth, say. They form something called a Widmanstatten pattern, which is basically all of the crystals of iron inside the iron meteorites form these kinds of patterns. And if you can etch them with various chemicals, then you can bring out these patterns, it's a very popular one to find. And if you've ever been to like an astronomy fair, you'll probably find somebody who's selling necklaces with these kinds of patterns on. But there were other types of meteorites as well that could be found. There's something called palisite. This is actually from the mantle layer, so between the core and the crust. And it's got the metal from the core, but it's also got these olivine crystals, which are the crystals of olivine, also known as peridot. And they're from that mantle boundary between the core. And there's not as many of these because they are very fragile. The metals in some places you can see is very, very thin. They tend to just fall apart. If it gets even slightly damp, it starts to rust as well, which is a big problem. So they're very hard to try and keep together. There's only actually been 61 known falls of this type of meteorite ever found. So if people are into collecting meteorites, this tends to be the one that's the rarer, the more expensive one, because it's A, pretty, and B, much rarer. But it can also teach us a lot about, again, a region of planets that we can't normally get in to see. Despite them being quite fragile, though, some of them are absolutely massive. There are also some asteroids which come from planets that did make it to be planets, or at least moons. There have been found meteorites that have fallen to Earth that are believed to have come from the moon and from Mars. And we know that they've come from there because we've been to the moon, we've been to Mars, we know what Mars rocks and moon rocks look like. So by comparing those to asteroids, we can see them. And this is one of the reasons why collecting meteorites and studying meteorites is so valuable, as well as getting a view into places that we can't normally see, like other layers of the planet. They also give us free moon rock. Yes, we do have a lot of moon rock from things like the Apollo landings and space missions, but those were very, very expensive to go and get rocks from the moon. We've never actually managed to bring a rock back from Mars. There's people who've been trying very, very hard, and in the next decade or so, that story might change. But right now, don't have any samples directly from Mars. But we do have Mars rocks on Earth because we have Mars meteorites. So they are very exciting and interesting ways of getting those kinds of rocks. We also think that meteorites might have been very important in the evolution of our own planet. They could have, in the early planet, one of the big problems that we have with planet formation is we can't explain why there's heavy metals in the crust, in the outer layer of the planet. Because when that differentiation stage happened, all of the metals should have sunk to the core. But then why do we have gold mines and iron mines? Why are they out in the outer layers? And one of the theories is that it might have been brought in by asteroids after the planet had largely cooled down. It might have been, a combination of various different factors, that including one of them. There's another reason why people, because as I said, it's the gold, things like gold and iron might have been brought by meteorites. That also means that things like gold and iron are out in asteroids, out in space. And so there's quite a few people who are talking about maybe going and mining asteroids. And there's sort of two camps on this sort of thing. When I first started doing this talk, this was a bit of a sort of throwaway comment of like, oh, people want to go and mine asteroids. But with every year, it's getting increasingly, if not probable, then possible, of people legitimately thinking about going to do this. And there's two camps. There's people who want to go out there and try and find asteroids that contain things like gold and platinum and stuff that's important for things like electronics, but is worth money. And then there's other companies who want to go and find things like water and steel and iron, because then those are resources that could potentially be used out in space. So for instance, if you want to build an infrastructure where you can start to build and fabricate things in space, it's much better if you can find your raw materials to do that in space. That one's a bit sort of more looking much, much further forward into the future of people like Elon Musk who want to go to Mars and things like that. So that's very much a long-term project, but it is something that people are thinking about. And there is another reason why people are interested in meteorites, which is we do know that they do tend to hit us occasionally. In fact, Chelyabinsk was a very vivid reminder that that happens. I'm sure we all know the story of the dinosaurs, or at least the commonly told story of the dinosaurs, which was that they were wiped out by a meteor hitting Earth, one that was a couple of kilometers in size. That's the point at which people start talking about the civilization-killing asteroids, the ones that are about a kilometer across. Thankfully, those occur about once every 20 million years or so. So the chances of one of those happening anytime soon is very, very slim. And in fact, people have done a lot of work to try and track them all down. These are all of the Earth-crossing asteroids that were known about. This is actually a couple of years out of date now, but this was all of the Earth-crossing asteroids over a kilometer in size. And we reckon that we know now about 99.9% of all of those asteroids, which could cause global problems if they struck Earth. And none of them look like they're heading our way anytime soon. So that's good. What people are concentrating now are on the ones that are about 140 kilometers in size, which is the orange band on this. And so there's a lot of people surveying the sky night after night after night to try and find these ones, because 140 meters in size, that's, if it hit Earth, it would cause local problems. If it hit a big city, it could potentially wipe out a city. So we want to know if those are coming as well. And I can't remember the exact number, but they reckon they found probably about 95% of Earth-crossing asteroids that are about 140 meters in size, and they will keep on searching until they know even more. And as I said, none of them look like they're coming to Earth anytime soon. But the reason why they're looking for them is not just so that we know it's coming, it's because we can actually do something about it now. So back in 2022, you might remember there was NASA's DART mission. This was a mission which sent a spacecraft to basically just crash into the moon of an asteroid. So it was one small asteroid, Didymorphos, going around Didymos. So Didymos was a central asteroid, Dimorphos was going around it. DART smashed into the moon and shortened its orbit by about 32 minutes. So that was the first time that we'd ever managed to adjust the path of something in space. And that's one of the easiest ways to deflect a potentially hazardous Earth rock. The best way to do it is know it's coming. Because if you've got enough time, you just need to make a small change to its orbit, to its velocity. And if you can see it 10 years in advance, that small change in its velocity means that when it comes by Earth and crosses Earth's orbit, Earth will be in a slightly different place and there won't be that collision. But in order to do that, you need to know it's coming in time, which is why they have all of these big surveys. So if there's no need to worry about asteroids happening anytime soon. I think instead it's much better to try and concentrate on them as a fantastic science resource and a way to learn more about our solar system and the way that our planet's formed. So thank you very much for listening. And if you want to find out more about planetary exploration, the ways that we've gone out and actually sort of explored them in person, then please do buy my book, Robots in Space. You should have the link somewhere. But thank you very much for listening. And if you have any questions about any of the stuff I've talked about, please do ask.